Hello students, in this video we'll balance the chemical equation for the burning of methane. Okay, so the burning of methane comes from the following unbalanced equation. It's CH4, there's methane, plus oxygen, produces carbon dioxide and water. And this is unbalanced, of course, and of course this produces heat because it's an exothermic reaction, right? And so this is unbalanced. And so it's our job to balance the chemical equation. And we do this using matrices in linear algebra because I'm going to have a linear system, right? So let's examine the equation. What we really have over here is I'm going to have X CH4, methane, plus Y of O2 will go into Z of CO2 plus W of H2O. So I need to find X, Y, Z, and W as integers, and I need to find them in a way that I make them as sort of as small integers as possible to get one solid reaction. Okay, great. And so now let's look at the equations. How many carbons do I have? I have X carbons on the left-hand side, and I have Z carbons on the right-hand side. So X is equal to Z. So X has to be equal to Z. That's one simple equation. All right, how many hydrogens do we have? We have 4 hydrogens over here on the left-hand side. And how many hydrogens do we have over here? We have 2W hydrogens over here. So 4X is equal to 2W. Great. And then what? And then so how many oxygens do we have? We have 2 Y oxygens over here on the left-hand side. And we have 2 Z oxygens over here. And then we have W oxygens over there. So those are our system of 4. Those are 3 equations and 4 unknowns, so I'm being able to find at least one parameter. And so what I'm going to do is I'm going to rewrite this as X minus Z is equal to 0, and then I'm going to write this as X minus W over 2 is equal to 0, and then Y minus Z minus W over 2 is equal to 0. So here's our system of equations. And now we're going to form our matrix, right? So our matrix now, typically people will typically say, like, let's just guess the answer. You can try to guess it. I like to do it more systematically than that because there's never going to be sort of a good way of just guess. I like to do things more reasonable, more logically, okay? So as a matrix equation, this becomes what? This is going to be 1x, no y's, negative 1 z's, no w's. That has to be equal to 0, okay? Then I have what? Then I have the next equation. I'm going to use this y equation since it lines up a little bit nicer. I have 0 x's, I have 1 y, I have negative 1 z, I have negative 1 half of w, and I have that has to be equal to 0. Then finally I have x, which is 1. Then I have no y's, no z's, and then I have a negative w over 2. It has to be equal to 0. So there's my matrix. And so I'm going to put this into reduced row echelon form. Okay. So what I'm going to do is I'm going to do negative row 1 plus row 3, and what will that give me? 1, 0, negative 1, 0, 0. First row doesn't change. Second row doesn't change. Okay, great. But now if I do negative 1, row 1 plus row 3, that one's going to turn to a 0. The 0 is going to stay at 0. Nothing happens over there. That's going to turn to a positive 1 over there. And then nothing happens over here, negative 1 half, right? 0. All right, now I'm going to do 2 steps simultaneously. Let's do row 3 plus row 2, and then row 3 plus row 1. Okay, so row 3 is going to stay the same. How is row 2 going to change? Row 2 is going to change. I'm going to add row 3 to it. So I'm going to get nothing. I'm going to get a 0, a 1, so a 0 and a 1, and then a 0 over here. And then I add these together over here. So what we get when we add these together. So I'm going to have negative 1 half and negative 1 half. Negative 1 half and negative 1 half is a negative 1, right? Good. And we do the same thing over here. So I'm going to do row 3 plus row 1. So row 3 plus row 1, I'm going to get a 1. I'm going to get a 0. I'm going to get a 0 over here. And then I'm going to get a negative 1 half over here. And then get those zeros stay the put. Okay. Now what I have here is I have a, now I'm in a reduced row echelon form. This is reduced row echelon form. Excellent. And so what I have over here is I see that in this problem, my W variable is my free parameter. So W is free to do whatever it wishes, right? And I can solve for X, Y, and Z in terms of this free parameter W, right? So W is my parameter T, so let's let W equal T. And then what can we say? Then I can say that X minus T over 2 is equal to 0. I can say that Y minus T is equal to 0, and Z minus T over 2 is equal to 0, which of course represents what? That says that X is T over 2, Y is equal to T, and Z is equal to T over 2. And now, and Z, of course, and W is just equal to T, of course, and we need W, X, Y, and Z to be whole numbers. Okay, so the easiest way to make that happen, of course, there's lots of solutions to this, but these have to be integers, and I can make this as an integer as long as t is a multiple of 2. And the smallest multiple of 2 will give us the most efficient way of writing this, and so I'm going to take t to be equal to 2. That's the smallest integer choice that's going to work over here. And if t is equal to 2, what does that say? That says that x is equal to what? X is equal to 1, y is equal to 2, z is equal to 1, and then, of course, t is equal to 2, so w is equal to 2. Now I can just fill in our solutions. I found the most efficient way of doing this, and of course you could say, like I could just guess, but now we have a much more efficient algorithm which works for general chemical reactions very, very easily as well. So our balance equation is what? Our balance equation is methane plus how many oxygens? Well, of course, y is equal to 2, so I need 2 of those O2s. Goes to what? Goes to Z, which is 1 of the carbon dioxide, plus what? Plus W, which is 2 of waters. And of course, we also get what? We also get heat. It's an exothermic reaction. And that's the balanced chemical equation for the burning of methane. Thank you very much.